All right, so today we're going to talk about some applications of similarity. And at first, there's really two key ideas that we're going to exploit to kind of create similar triangles in situations. The first is that light travels in straight lines. We will exploit that. What other things will we exploit? We will also exploit the assumption that things like buildings and flagpoles and people are going to be perpendicular to the ground. Okay, so if there's a telephone pole, you're going to assume that that is perfectly perpendicular to the ground, which is a fairly reasonable assumption to get at least a good idea of how big something is, let's say. Okay, so using those two key ideas, we have two sorts of problems that we're going to kind of, I'll draw some pictures here, and then we'll do a couple examples, and you'll try one on your own. There are certain problems where you have, let's say, a mirror. So let's kind of draw, like, let's say, here's you on a building, that's you, or me, or someone, the observer. And then let's say we also have, like a flagpole or something like that. Well, what's cool is if there were, let's say there were a mirror right here on the ground, what you could do is if that mirror was positioned in such a way where you could see down and the reflection off of that mirror would show the exact top, let's say, of that flagpole, well, then what's interesting is you would actually be forming some similar triangles using the assumptions that we talked about before. First of all, we've got some right angles. Why? Because we're assuming the building that you're on is perpendicular to the ground, and so is the flagpole. And then similarly, pun intended, the angle of incidence is the angle of refraction. So you have two triangles that are similar by angle. Therefore, the ratios of corresponding sides will be equal, so you'll be able to make some sort of proportions to figure out, let's say, the height of the flagpole, or perhaps a distance here, a distance here. So you'll have three unknowns, and then you can use similarity because these two things are similar by angle similarity. More commonly, there are these sorts of shadow problems. For instance, like here's a light post. Really great drawings today. I actually can draw, by the way. And so we have a lamppost here, great picture. And then we have like you, the human. So what's cool is, since light travels in straight lines, the light from the lamppost will travel in a straight line to the top of your head, and from the top of your head it'll travel in a straight line to the ground. So then what's cool is you can have situations where you can tell, what your shadow is, let's say, and then you can use that to figure out the distance from the flagpole and things like that. So what I mean is, like, let's say you wanted to figure out your shadow, actually. Well, you could figure out this distance that you walked away from the flagpole. It's possible you might know the length of the flagpole, and, you'll know your height. So out of these four measurements, you can actually make some similar triangles. Kind of think of this big triangle right here with the lamppost, the distance from you to the lamppost, and your shadow. Maybe you want to find your shadow, and that's x, to this smaller triangle here where you know your height. You're trying to find x, which is your shadow. Then, again, these two triangles will be similar. By angle, we assume our perpendicularity. And since light is traveling, I guess, actually, yeah, you can get this angle to be the same because, the light is traveling in a straight line. So you do, in fact, get the same angle here on both triangles by the reflexive property. So again, the triangles are similar by angle. So this is like a good conceptual beginning. And I mean, in the end, you're going to get similar triangles, and you're going to make some sort of You're going to make a couple of ratios, you're going to make a proportion, and you'll be able to solve for the missing thing. So this is like indirect measurement, and it's actually like very powerful, and you can figure out some really crazy things, which we're going to kind of introduce you to here, but you can really extrapolate on this and figure out, really far distances and things like that that actually happen in real life. All right, so in this situation, you always have to start with drawing a picture, kind of like how I drew pictures on the last one. Okay, Mr. G's got a height. He wants to figure out the height of a tree. He's got a tree. It's in his backyard. Here's Mr. G. Mr. G, I apologize, this picture's terrible. So we know Mr. G's height. So here's Mr. G's shadow. Here he is. So Mr. G, we've got his height. He determines the shadow of the tree, so he could measure that. Okay? And I guess what we're going to do is try and figure out the height of the tree. So we can put an X here for the height of the tree. That's what we're trying to find. Now, Mr. G's shadow is 2 feet 9 inches long. To be careful, that is not 2.9 feet. That is 2 feet and 9 inches. That's 9 out of 12. So Mr. G's shadow is 2.75 feet when it's all said and done, because 9 out of a possible 12 inches is 3/4. Mr. G's height is 5 feet 8 inches. That is not 5.8 feet. That's going to be 5 feet and 8 inches out of a possible 12 inches. That's going to be 2/3. So Mr. G's height is 5.66 feet. Okay, and we know the shadow of the tree, because we can actually measure that because it's on the ground. So it really makes sense. We really could measure this. We would know Mr. G's height. We can measure this, but we can't measure the height of the tree, but indirectly, using similarity, we can kind of figure that out. Okay, and the shadow of the tree is 6.5 feet. And actually, I purposely did that wrong. No, it's not 6.6 feet. It's 6 feet, 6 inches. 6 inches is a half a foot. So be careful. We don't have a metricness here. So again, this is not 6.6 feet. So now we really just have two triangles. We know that, the sun is shining and it's roughly going to hit the tree and us at the same angle. So we would have angle-angle similarity here. So then we can just make a proportion. We can say the height of the tree to the height of Mr. G is going to be the same as the shadow of the tree to the shadow of Mr. G. So again, we are comparing the tree to the man. Always make sure that in your numerator you've got your tree information, X, height of the tree, and in the denominator you have the information about the man, Mr. G. So tree to man, those are heights. Tree to man, those are shadows. They will be proportional. So we can actually figure out X. So an exercise to you, the reader, in order to get full credit on this homework, you need to figure out how many feet, and maybe even write a nice sentence. What is the height of the tree? So nice final sentence. The height of the tree is blank feet. So cross multiply, maybe use a calculator and kind of figure out that information. Go to 2 decimal places in feet. Good luck. So again here we have some similarity, things with shadows predominantly, but there's also mirror type problems. It's important for you to know about both. In this situation, I've kind of made the picture already just to be a little neater. So here's me. Great picture. And I know that I'm 2 feet away from a lamppost. There's my lamppost, or a light source. We know that the lamppost is 8 feet tall because we call town hall. And we know that that's how high all the lampposts are on our street. We also know, remember that I'm 5 feet tall, 5.5 feet tall, so I'm just going to go right to 5.5 feet there. Again, all of these are in feet. And so what we're trying to find is how long Mark's shadow is. If I'm standing here, here will be my shadow. That will be x. So we're going to kind of say let x equal Mark's shadow. And again, that's going to be in feet. Units are really important. Okay, so now I recommend in any similarity problem like this, you kind of break this out into two similar triangles. I suppose I could draw that a little bit better. So, two similar triangles here. Maybe I'll make the second one smaller. No, you know what? It's fine. So, on the larger similar, let's do the smaller similar triangle. There's my height of 5.5 feet. There's my shadow. I don't know what it is, so it's x. Now, in the big triangle, we know the height of the lamppost is 8 feet. But be careful. This entire height is not 2 times x. It does not make sense to multiply. Naturally, you should add. So we would have a 2 plus x here. Okay, so from here, we know we have similar triangles. We know the heights will correspond, and these distances on the ground will correspond. So we can do 8 over 5 equals 2 plus x over x. From here, if we cross multiply, we'll have 8 times x will be equal to 5 times, I'm going to group that 2 plus x together to remember to distribute. So we'll have 8x equals 5 times 2 is 10. Distribute the 5 to both parts. Get a 5x on the second portion. If we subtract 5x from both sides, we'll have 3x equals 10. Divide by 3. So x is going to be 3.333 feet. So if you could, on your assignment for full credit, could you actually write a final sentence to say how big my shadow is? So something like, finally, Mark's shadow is 3.333 feet tall. And so, you know, there could be different permutations of this problem. It would naturally make sense that you wouldn't call City Hall. So maybe you knew your height, you could measure that distance on the ground because you have measuring tape. You could also measure your shadow or have a friend do it. So then you could figure out the height of the lamppost. So there's different permutations to this problem, but in the end, it's similarity at its best, knowing that the ratios of corresponding sides are equal. So that's how we set up our proportion, and we can solve for the missing piece. So on the next slide, there's something for you to practice on, one problem for you to try. Make sure you do it completely, and pay attention to units and converting. So again, to begin this problem, John is not 5.9 feet tall. You'll need to convert that. So don't say 5.9. Also, don't say that the tree is 12.4. Make sure you start out by drawing a picture, maybe breaking it into a couple of triangles. Show your proportions, show all work, and good luck on this. Remember, you must do this to have full credit.